Imagine standing before a doorway that doesn't lead to another room or another planet, but to the very edge of reality itself, a place where everything you know about physics, time, and space completely falls apart. This isn't a fantasy, this is the unimaginable world of a black hole, a cosmic monster born from the death of a massive star. When such a star runs out of fuel, its core collapses under its own weight, shrinking smaller and smaller until it becomes so dense that nothing, not even light, can escape its gravity. And from that collapse, a black hole is born, a region of space where the rules simply fail to make sense. At the heart of every black hole lies the singularity, a point of infinite density where all the mass of the collapsed star is squeezed into a volume smaller than you can imagine. Surrounding this terrifying point is the event horizon, the invisible boundary of no return. Once anything passes this boundary, whether it's light, gas, a planet, or even an entire star, it can never escape again. It simply falls inward forever, pulled irresistibly toward the singularity. And this is what makes black holes so mysterious. Even though they are invisible, their presence is impossible to ignore. Scientists know black holes exist because of the way they affect their surroundings. Imagine a star orbiting an empty patch of darkness, pulled tightly in a fast circular path. The only explanation is that something extremely massive is hiding there. And when gas or dust gets too close, it spirals toward the black hole, heating up to millions of degrees and shining brightly before disappearing forever. Astronomers have captured these deadly disks glowing around the edges of black holes, giving us the closest look we can ever get at these cosmic beasts. Black holes also come in different sizes. Some are only a few times the mass of our sun, formed by collapsing stars. Others grow to unimaginable scales, becoming supermassive black holes, millions or even billions of times more massive. These giants sit quietly at the centers of galaxies, including our own Milky Way. Their gravity shapes the motion of stars and helps build the structure of entire galaxies. They aren't just destroyers, they are architects of the universe. Approaching a black hole is where things get truly bizarre. The gravitational pull becomes stronger the closer you get. If you were falling feet first, the difference in gravity between your feet and your head would stretch your body like spaghetti, a process scientists call spaghettification, but this only happens near small black holes. If you fell toward a supermassive one, the tidal forces near the event horizon are surprisingly gentle. You might not even notice crossing the boundary, though from the outside perspective, time would appear to slow down for you, eventually freezing completely as you faded from view. Time itself bends in the presence of a black hole. The stronger the gravity, the slower time passes. This isn't science fiction, it's a real effect predicted by Einstein's theory of relativity. Someone watching from far away would see you slow down more and more as you fall in, but from your point of view, time would feel completely normal until the moment you reach the singularity, where the laws of physics break down entirely. Black holes can also collide. When two of these cosmic monsters spiral into each other, they send ripples through space, known as gravitational waves. These waves travel across the universe, stretching and squeezing space as they pass through Earth. Scientists detected these waves for the first time in 2015, confirming one of Einstein's most astonishing predictions. The waves came from two black holes merging over 1 billion years ago, yet their collision still echoed across the universe and reached us today. Some theories go even further, suggesting that a black hole might be more than a dead end. Some scientists think that inside a black hole could lie the beginning of a new universe entirely separate from our own. Others imagine the existence of white holes, the opposite of black holes. Instead of pulling things in, a white hole would push everything out, refusing to let anything enter. Though none have been observed, these theories show just how little we understand about the true nature of black holes. Black holes don't live forever either. Even though nothing can escape from within the event horizon, black holes can slowly lose energy through a process called Hawking radiation, proposed by Stephen Hawking over 40 years ago. This radiation is incredibly slow for big black holes, meaning they could take trillions upon trillions of years to fully evaporate, long after every star has burned out and the universe has gone cold and dark. In the end, black holes are more than just terrifying cosmic traps. They are windows into the deepest mysteries of reality. They challenge everything we think we know about physics, pushing the limits of our understanding and forcing us to confront the strangest possibilities in the universe. They are reminders that the cosmos is still filled with secrets, and that the more we learn, the more mysterious it becomes.